Welcome to section 9.5. In this section, we are going to learn properties of tangents and how to use those properties to solve problems. So to review, a tangent line intersects a circle at exactly one point, called the point of tangency. In this example, the tangent line is AB. So this is the tangent line. And the point of tangency is point A. So the place where the tangent intersects the circle. And a line is tangent to a circle if and only if it is perpendicular so this means that it makes a right angle with a radius drawn to the point of tangency. So our radius is AP. There's our radius. And we have a right angle here that indicates that AB is a tangent to the circle at point A. The symbol for perpendicular, if you remember, is this upside down T. All right, so let's see what we can do with this. In questions 1 and 2, we want to determine if AB is tangent. So in other words, we don't know. We want to know if it is. So here's AB. And so in order to determine if AB is a tangent, we need to show that this angle here is a right angle. So at this point, we don't know. So how can we show this? Well, if you notice, we have a triangle there with sides 8, 15, and 17. If we can show that the triangle is a right triangle, then we can show that A is a right angle. And we can use the converse of the Pythagorean theorem to show if this is a right triangle. So we would say is 8 squared plus 15 squared equal to 17 squared? Well, yes, we don't even need to do the Pythagorean theorem because it is a triple. So that means that 17 is the hypotenuse and this is a right angle. So we use the converse to show that AB is a tangent. So we know that angle A is a right angle. Therefore, AP and AB are perpendicular. Therefore, AB is a tangent. Okay, so in number 2, we'll use a similar logic. This one's a little bit trickier in that if you notice, this side here is not giving us the length. But we do know that if 11 is a radius, this part of it has to be 11 as well because it's also a radius. So this side is actually 16. So again, we want to use the converse of the Pythagorean theorem to show that angle A is a right angle or to show that it is not. So let's see, 14 squared plus 11 squared. We want to know, is that equal to 16 squared? So that's 121, 256. We don't know yet. That's why there's a question mark there. And, oops. My apologies. I did this out of order. Okay, let me just try this over. So 14 squared is 196. 11 squared is 121. We don't know if that's equal to 16 squared, which is 256. And let's see here, this is 317, and that is not equal to 256. So what does that mean? It means that angle A is not a right angle, okay, because that's not a right triangle, and it means that AB and AP are not perpendicular, which means AB is not a tangent. All right, in the next set of problems, we are told that JK is tangent. So in each of these cases, we know that JK is tangent. If that is the case, we know that this is a right angle because a tangent is perpendicular to a radius at the point of tangency. This is a right angle. This is a right angle. And this is a right angle. Again, it is given that that is a tangent. So now we are going to use, you guessed it, the Pythagorean theorem to find the measure of x. So in each of these cases, here we go, 7 squared plus 19 squared equals x squared. Remember, the hypotenuse is your c. So 49 plus 361 equals x squared. And 410 equals x squared. So to find x, we're going to take the square root of both sides. And x equals about 20.2. It says to round to the nearest tenth. All right. Now, in the next problem, this is similar to the one above. They're not giving us the hypotenuse, so think about it. What is the length of the hypotenuse? They're only giving us this line segment here. Okay, so maybe pause the video and see if we can figure out what the entire length is. All right, so yes, you got it. This is a radius, therefore it is 11, so that hypotenuse is 18. And again, x squared plus 11 squared equals 18 squared. Pythagorean theorem, x squared plus 121 equals 324. Subtract 121 from both sides. X squared is 203, and take the square root of both sides. So x equals about 14.2. All right, so why don't you pause the video and figure out what's going on in number 5. So label any missing segments, set up your equation for the Pythagorean theorem, and then solve. And then when you're ready, turn the video back on. All right, so what do we have here? We know that this tangent segment here is x. The hypotenuse is 25. However, this leg here is what? Yeah, that's a diameter, which means if the radius is 11, this is 22. So your equation would be x squared plus 22 squared equals the hypotenuse squared. Okay, so subtract 484, and that gets us from 625, 142, square root, and x equals about 11.9. All right, again, turn off the video and try to figure out number 6 on your own, and then when you're ready, or if you need a hint, turn the video back on and check your work with the video. All right, so again, this LJ is a radius, which means if that's 3.5, this is 3.5. So the entire leg there is 7. And so the leg squared plus the other leg squared is the hypotenuse squared. All right, how did you do? All right, so the party hat rule, okay, this is not the mathematical name for it, but it is a theorem that says that if we draw two segments from the same external means outside of the circle, in our case, this is the external point. If we draw two segments that are tangent to the circle, so in other words, BC is tangent to the circle, and so is AB. So what do we have here? And again, they're perpendicular to the radii. That's how we know that they're tangents. So what we can conclude as a result of that, so in this setup, these tangent segments have to be congruent. All right, so we're going to use that, for example, in number 7. So it says that assume that the segments that appear to be tangent are actually tangent. In other words, AB and CB are tangent to the circle. So what does that mean? Well, they're congruent. So our equation is 5x plus 23 equals 8x minus 19. And so let's go ahead and subtract 5x from both sides. And then add 19 to both sides. So 3x equals 42. Divide by 3. X equals 14. And in this case, we're only finding x, so we're done. In number 8, we have the same setup. So we call this the party hat because it looks like a party hat. So here we go. These are congruent. They tell us that we can assume they're tangent. So that means that 14x minus 13 is equal to 8x plus 5. The difference here, though, is we're not just finding x. We are going to find PQ. So subtract 8x from both sides and add 13. And so we know that 6x equals 18 divided by 6. X equals 3. Don't stop. PQ is 14x. So 14 times 3 minus 13. You could actually use, oh yeah, that's actually a good idea. Since they're congruent, wouldn't it be easier to just use 8x plus 5? Oops. So that would be 8 times 3 plus 5. That's easier to work with. So that would be 29. And there it is. PQ is 29. Okay. The other property here is that if a polygon is circumscribed, so what does that mean? It means that the polygon is drawn around the circle and it touches the circle. Each side touches the circle. So this has 3 sides, so it will touch the circle in 3 places. In other words, the sides are tangent. So what's going on here? Well, we can use the quote-unquote party hat rule here. So this is congruent to this. There's one party hat. This is congruent to this. There's your other party hat. And this is congruent to this. So in other words, as you go around, you have congruent tangent segments. All right, so let's see how we use this property. So if we're going to find the perimeter of DEF, so DEF is this polygon that is circumscribed around the circle, circle J. So we know that this segment and this are the same, so that's 11. Okay, this segment and this are the same, so this piece is 16. This segment and this segment are congruent, so this is 9.5. Perimeter is the distance around. So what do we have here? Well, we have doubles of everything. So we have 2 segments that are 11. We have 2 segments that are 16. And then we have another 2 segments that are 9.5. So we have 22, 32, and 19. And so the perimeter of triangle DEF is the sum of those sides, or 73. All right, let's see, what can we do with number 10? So number 10 is a little bit different. Notice what they're giving us here. They're giving us this entire side. So we can easily enough find this segment here, right? But do we really need it? I wonder, do we need it? Yes, we do. Think about it for a minute. Maybe turn off the video while you're thinking about why might we need to figure out what that piece is. All right, so that piece has to be 27.1. And why do I care? Well, if I know that that's 27.1, I can find this piece. And it's important to know that right here, because it's the same with this. And I don't have that. Okay, so let's see. So this segment here is going to be 52.5 minus 27.1, or 25.4. So that means this is 25.4. Okay. I need to use the same logic to find this. Okay, so 23. And then this piece here is going to be 37.5 minus 23. Make sure you line up your place value there. So that's 14.5. And so this has to be 14.5. So that's the only way to find these missing segments. So this one here and this one here. All right, so now I can add all those going all the way around. And so the perimeter, when I add everything together, I should get 180. Check it out. Make sure you get 180. So you're adding all the way around. Make sure you don't add things twice. So if you're adding 52.5 here and 37.5 here, that's it. And then you're going to add the sum of this and this, and then this segment and that segment. So that should get you 180. All right. Well done.